All right, in this video tutorial, we're going to go over the big ideas geometry section 10.2, finding arc measures. Two main learning objectives are to find arc measures and then to identify congruent arcs. So first, let's talk about where arcs come from. In order to create an arc, you have to have a central angle. And a central angle is any angle where the vertex or your middle point is on the center of the circle. So notice this diagram down here below. You have an angle ACB. This C, or the vertex, must be at the center. And depending on the size of the angle, you could have minor or major arcs. Minor arcs are anything less than 180 degrees. Major arcs are anything greater than 180 degrees. If you have exactly 180, it's called a semicircle. That's just a diameter that is from endpoint to endpoint of the circle going through the center. So we're going to find the measure of each arc of this circle P, where RT is known as your diameter. These boxes, the formatting was weird when uploading to PowerPoint, but imagine that it is a curved line to indicate that it is an arc. So first we're going to look at arc RS, which is this red one right here. It is a minor arc because it's directly related to this 110 degrees right here. So it is equal to the RPS angle that it is corresponding to the central angle. RTS, traveling from R to T to S. Since you know that this is a diameter and this portion is exactly 180 degrees, it's more than that, so we know that it is a major arc. And it is all that is left over from taking your 360 away from 110 to get 250 degrees. RST is traveling in this direction from R through point S through to T, and that is a semicircle since RT is your diameter, which means it's exactly 180. All right, another core concept is looking at adjacent arcs. Adjacent just means that they're next to each other, so arcs that are intersecting at exactly one point. So AB and BC meet at the point BC, and you can get your total ABC by adding those two things together. So again, we're looking at the measure of each arc in this circle. Let's look at arc GE first, which is the red one going from GH to HE. And we're given that these individually are 40 and 80 for arc GH and HE. We can just add those two together to get your total of 120. Now on to GEF. Again, it's nice to know the order. So when you're traveling through, you're starting at G, going through E to F. If you just say GF, that means you're finding the shortest distance, and it's just going this direction, which gives you a completely different arc measure. So finding that is going to be the arc of GE plus the EF. We know that GE was 120, add it to your 110 to get 230 degrees. So now GF, like what I was saying earlier, is it is the shortest distance, and it is going to be your leftover from what this one of 360 minus what we found in GEF to get a 130 degree arc measure. So arc measures are also useful when looking at a pie chart. So if you have a survey and you're trying to collect the data, when asking teenagers whether they'd rather meet a famous musician, athlete, actor, inventor, or another person that's not categorized in those, this is a result of what an example survey would give you. So we're going to find the indicated arc measures based on what each one of these color pie charts are corresponding to. So measure of arc AC is going from A to C, again in the shortest point, not going from A all the way around to C. This one is shorter. You're going to add your AB plus your BC, which is 29 and 108 to get 137. Part B, we're going to find measure of ACD. So that means we're going from A through C to get to D. And you're just going to add all of those parts together. 137, which is what we just got, plus 83 to get 220 degrees. ADC goes in the opposite direction, AD and C. And you can find that by taking 360 minus the opposite one that we just found, 137, 223 degrees. And the last one, measure of arc EBD, starting at E, going through B, and then to D. you can take your 360 minus this 61 section, because you know that all those have to add to 360, and you get 299 degrees. All right, so now looking at whether indicated arcs are going to be congruent and explaining why or why not. So we're looking at part A to look at this arc CD and the arc EF. Well, since we are given that both of the central angles are congruent to each other, the arcs also have to be congruent to each other since they are the same indicated measure. So both of those arcs are congruent. Part B, we're looking at the measure of this circle on the inside of that circle right there, and this arc RS and TU. They are the same measure because even though they do have the same central angle, the distance between them is going to be different because of your radius distance being different. So they are not congruent because the circles are not congruent. And then part C, you're looking at two separate circles where the given radius of each one of your circles is congruent and the central angle is also congruent. So yes, the arcs are congruent.